If you take it, would they still count it?
It's not even on the. Hold on, I'll show you.
It's not on assist.org?
Yeah, they completely removed it. The old assist.org had it. Where did I put it? Oh, here it is. Yeah, so this is the. So they said they no longer require these classes anymore, but they basically.
But it doesn't have any.
Just cisp360 is the only one that's required now.
Huh. And you're getting into electrical engineering?
Mm-hmm.
Okay.
But they wanted cisp310 last semester and the semester before that.
You can talk to the professors over there because they can actually do things on a case-by-case basis.
So you mean I could take it here?
You probably want to check with them first.
Okay.
I think I have one student exactly in that situation right now with UC Davis. They want me to send them their my syllabus and the curriculum so they can evaluate and whether they want to count it in or not.
Oh, that would be helpful.
Yeah.
Okay.
Well, you can ask them to talk to me directly, and I can show them what I teach you.
I would hope, since you were a professor there at one, or a lecturer.
I was a lecturer over there.
Well, I like how you go. Well, but you were a professor.
Lecturer is different. You don't get to go to the meetings.
Oh.
Yeah.
Are you going to catch up on grading homework so that we know how we're really doing in the class?
Getting there. So Hello World is done.
I don't really care about that one.
Yeah. Well, it's going to take some time. I just finished all the exam questions, so that's all done. Yeah, it's actually recording right now, so that's good. So the exam 1 is all graded at this point. So when you go to your gradebook, you will see exam 1 having its own category. And then inside exam 1 will be the 4 questions, X1Q1 to X1Q4. Each one has a different point value, but they are all weighted the same way. Okay, so they are basically account for the same amount of grade inside, exam 1. And most people look at their score and go like, oh, until they remember, what it takes to get a C and a B and an A, which is different from many of your other classes. So no, it's not.
Oh no, it's just funny. The questions that I thought I did bad on, I did good on, and the ones I thought I did good on, I did bad on.
Oh.
Yeah.
Well, that's a good trade. I mean, it's
yes.
not bad. It's not too bad. So there you go. It's already done. I'm catching up with my grading, but I always give you the solution of the homework assignment first, so that at least you know what it is supposed to look like, and I'll explain it as well. So that's the first thing we'll do today, is to go back to the homework assignment, which is limited summation, and then we'll talk about new homework assignment. They are closely related, so when I explain the first one, it will definitely help with the second one. All right. So with that in mind, we are going ahead to. I am redoing the whole thing, so I'm deleting the whole folder that I did earlier this morning, and start from scratch. Okay. So let's go ahead and read the specification of this program. Limited summation wants you to create a folder called sum, and inside you have one single source file called main.cpp. You can include additional files if you want to, like test cases and whatnot, if you want to. But in this case, well, I suppose you can have actual test cases with this program. So you can have test cases within that the folder. It doesn't really matter. I'm just looking for main.cpp. So let's go ahead and get started with this one. Make a folder, sum, go to sum, and then we edit main.cpp. In this homework assignment, it is also very clear that you are to use printf and scanf in this assignment. Do not use cin or cout. Okay, so that part is important. If you want to use scanf and printf, you have to include the stdio.h file, which stands for Standard Input Output Header File. Okay, but it's abbreviated to stdio.h. And then we start the main subroutine. And the way I write subroutine is always like that. I always close a close parenthesis or close curly braces in this case, as I start the first one. So this way I don't have to worry about closing it later, or the indentation is wrong, or anything like that. Within a program, the first thing you have to do is to prompt a user to input a maximum number of entries, and you want to use the prompt, the maximum number of entries, max pound entries. So I'm going to do exactly that. A single printf will do that. So max pound entries, and that will just print it. Now, if you do not end a string with \n, which is a line feed or new line character, the cursor will appear at the end of this line, which is kind of perfect for a prompt. Okay.
So what will happen if we? What did you just say?
If you do not have a \n at the end of this string here, if you do not do this, instead you just leave it the way it is, like this. Leave a space; it looks better this way. Then the scanf on the next line will prompt the user on the same line, so it definitely will look right. Okay, so now we need a scanf. I do not require any type of error checking for the scanf here, so there's no need to include error checking logic. If you want to, that's fine. Okay. So we want to read it into something, and immediately I know, okay, I'm missing a variable in this program. So I use a particular max entries to remember how many entries we're supposed to have. Well, this is the maximum number of entries for the summation, and then we specify ampersand max entries. Okay. Now this may not be good for like copying, because I keep going back and forth. So if you're just copying on a piece of paper, you might have to insert. Use some kind of notation to say insert here, because the way I write programs is exactly that. Okay, I do not start from line 1 and then go all the way to the last line. Many times I go back and forth. Okay, as I need a new variable, I go back to declare and then make use of it. The next thing we do is a printf threshold. So we have to find out when are we going to exit the program, because when the summation reaches threshold, we are supposed to exit the program. And once again, I need one more variable, so I go back here and just name this one threshold. With C++, you don't have to do it this way. With C++, you can declare variables anywhere you want to. Okay, let me explain what I mean by that. What I mean is, if you need threshold right at this point, you can actually, if you want to, put the declaration over here. That is permissible in C++. It is not permissible in regular C. So when you are using GCC, it will complain about this syntax. When you're in G++, it will say it's okay. Is that okay?
Why is it not like it in C, but it's fine in C++?
I do not know why in C it is not allowed, but in C++ it is definitely okay to do it this way. In regular C, you have to put all the declarations at the beginning of a scope, open curly brace. You cannot interleave actual statements with declaration of variables. But in C++, which is what we teach in this class, it is okay. Personally, I do not like it this way. Personally, I like it this way better. But there's no, if you do it either way, I'm not going to take any points off. So this will take care of reading in the maximum number of entries, and also reading the threshold, which do not require error checking. So the next one is going to be the actual difficult part of the homework assignment, or the starting point of the difficult part of the homework assignment, which is, okay, let's read entries until the sum has reached either the threshold or we have read the maximum number of entries. Okay, so what kind of control structure do we need? Okay, a loop of some kind. Okay, you can do it with a while loop, or you can do it with a for loop. It's up to you. I'm going to do it with a for loop because when I was grading question 3 of exam 1, from how people update the variables, I think quite a few people misunderstood how a for loop works. Okay, so I want to kind of clarify how a for loop works by using a for loop in this particular case. So with a for loop, this is the way I write programs, which doesn't really help when you're trying to copy it on a piece of paper, because I keep inserting new stuff, right? but it really is the important part. Is the understanding of the concept is much more important than the actual code, because the recorder is up and running, so the actual detail will still be recorded. Okay, this is a for loop, and the question is, what is the first part of the three things inside the parentheses? Initialization, and that happens before we get into the loop the first time. Okay, so in this case, what kind of initialization would be appropriate? You look at all the variables that we have up to this point, and which ones do we need to initialize? None of them, right? Because we only have two variables at this point. We have max entries and we have threshold, and both of them get their values from reading from the standard input file. So that means we need more variables. Now, when you need more variables, this is also a difference between C and C++. In C++, you can actually declare variables at this point, but in C you cannot. Okay, in C you have to declare variables before you get to a for loop. What other variables do we need with this program? A counter for the number of entries and a total, a sum. Okay, very good. So we'll go ahead and declare those. So we have sum, and then we also have basically number of entries or counter. Okay, so I'll just call that entry counter. Okay, there we go. Now, many people like to do initialization here. I personally do not, and the reason why I don't like to do initialization over there is because that gives me a false sense of security. Because I look at the code and it looks like, oh, it's initialized. Well, it is initialized, but does it need to be reinitialized somewhere else? Maybe, maybe not. But seeing the initialization at the declaration point gives me that false sense of security. It may not work the same way with your mindset, but with my mindset, I don't like to do it that way. So I always do the initialization as close as possible to the context where the variable is needed. So right now, at this point on line 13, would be a good place to initialize both sum and entry counter. Sum should start with a 0, and entry counter should start with 0 as well. Entry counter does not have to start with 0. It depends on whether you feel comfortable counting from 0 or feel more comfortable counting from 1. But there is one side effect. The way you do the comparison does change depending on whether you count from 0 or 1. I like to count from 0 because that's just the way it is for programming. Okay, what about this part here? Okay, I'm separating it into multiple lines. What about the second component? What does it specify?
It's the condition.
The condition to stay in the loop or the condition to get out of the loop?
However you want it, right?
To stay in the loop. It's like the while condition. Remember, a for loop is really a while loop, except we are putting things into different places. Just syntactically, it looks different. So this is the condition to stay in the loop. Now, in the question, I specify the conditions to get out of the loop. So what that means is you have to take the negation of these conditions and then do a conjunction instead of a disjunction. Okay? So that means we have to see whether, in order to stay in the loop, I want the maximum number of entries not to be reached. Does that make any sense? Okay. And so here we know that we have to compare those two things. We have, on one hand, we have entry counter, which counts the number of entries already entered in this program. We also have another variable related to this one, which is max entries, the maximum number of entries. The question is, how do I specify the comparison so that I stay in the loop as long as I have not reached the maximum number of entries?
Counter needs to be less than the max entry.
Less than, exactly. So it has to be exactly less than in this case and not less than or equal to. If you initialize entry counter to be 1, then you want to look for less than or equal to. But since we initialize entry counter to 0, we only need less than and not less than or equal to. Very good. There's one other part to it. Okay, so I'll put question marks here. And the other part has to do with the threshold. The threshold will be compared to sum, So once again, I need to figure out, what to specify as the comparison. I want the sum to be always blah blah blah, the threshold to stay in the loop.
Less than.
Once again, it is less than, because if it is greater than or equal to, we exit the loop. All right, so now the remaining part is how do we combine these two comparisons so that we have one single condition to specify when do we stay in the loop. Well, we only have two real choices here, right? We have either conjunction or disjunction. Which one?
A disjunction, right? Because it could be either or.
If you specify disjunction here, that means I stay in the loop as long as I have not reached the threshold, or as long as I have not reached the maximum number of entries.
Isn't that what that? Did I read the assignment wrong? Is that what the assignment was?
Well, in the assignment, that specifies the exit condition. So the exit condition implied by the word until says at least one of the following condition is true, but that's specified the exit condition. But in a while loop or for loop, we are looking at a stay in loop condition, which is the negation. We want an and, right? Because we want both of these conditions to be true to stay in the loop. If I specify an or here, that means I will be able to exceed the threshold, but as long as I have not also reached the maximum number of entries, it will still stay in the loop. Is that okay? There are two ways, at least two ways to specify this logic, but I think this is the easiest way or the most straightforward way. The other way to specify this is to specify entry counter is greater than or equal to max entries, or sum is greater than or equal to threshold, and then you put an extra level of parentheses on the outside and put a negation. So that would be the other way to do it. Yep.
Are parentheses necessary?
In this case, it is not necessary. But I don't trust my own memory for remembering, how the priority of operators. So whenever I have doubt, I always put in extra parentheses, because extra parentheses cannot hurt. Okay, it might clutter up the code a little bit, but it never hurts. And with an editor like VI, where it can match the close of the beginning, it's not easy. It's not difficult for me to figure out, how it's nested. So I would much rather put in extra parentheses than to take the risk of I might remember the priority of operators incorrectly. But that's just my personal issue of not, spending the time to memorize all the operators' priorities. All right. What about the third component? We have one more component here because we got three things inside the parentheses with a for loop. What does it mean, and what should we specify here? First question first. What does it mean?
So what do you do when you go into the loop? So
What do I do after each iteration? Okay, this is after each iteration. It's a post operation. So in this case, the post operation is really just to increase the number of entries. So I'm just adding one to entry counter. In this particular case, it really doesn't matter, whether I do it at the end of each iteration or at the beginning of each iteration. But in the question of the exam, it does matter, and it is after each iteration. The operation is performed after each iteration. In other words, if I have a block of code here, this ++ entry counter is performed after BLK is done, not before. That's why it's called a post operation. All right. So now what do we do inside here? This is where you can copy and paste my code from Monday. How many people did sort of like that?
I couldn't figure out where to put it, so.
Oh. Well, this is where you copy and paste the code, because ideally speaking, this is what we want to do. If we do not expect the end user to put in anything other than valid numbers, this is all we want to do, right? Scanf. Now don't copy this, because I'm going to have to make some major changes to this section, so leave a lot of space. In fact, write a little arrow to that thing and go to see next page. So what I want to do is to read a number, okay, and Then we say, sum plus equal to that number. That's what we want to do. And since we don't have a number to read into, let's go ahead and declare it here. That's all I need. Because you can see, not sum, num. Okay, let me go back and change this to num. You can see from the context of this code that num as a variable is only needed within these 3 lines. It has no use other than these 3 lines, so that's why I define the variable, or I declare the variable only on line 18. So this way I can, elsewhere in the program, I can also have another num that has absolutely nothing to do with this one. Go ahead.
Line 20, is one of the second one is num.
Oh, num, yep, that should be num as well. Thank you. Otherwise it doubles some, right? All right. So ideally speaking, this is what I want to do. But in the homework assignment, I said you have to do error detection and you have to handle it. You don't have to report, okay? There's no need to warn about, oh, I got something that is not a number, but you have to at least detect it and at least ignore it. In other words, you basically throw away all the junk characters until you get to the next number. That is what you need to do. And that's also kind of what we talked about on Monday. I gave you guys that piece of code that you can pretty much just kind of copy and paste here, except for sum plus equal to num. That's the extra part that you have to do in this case. All right. So we cannot just do it like this. We have to now basically surround this with a while and make it a loop. In other words, as long as I'm not reading a number properly, we'll do something, okay? But what exactly are we going to do? We have to read the junk character and toss it away and then attempt to read an actual number, okay? So if you don't want to print any error messages, the minimum that you have to do is to say, either use int 8_t or char, you choose which one you want to use. If you use int 8_t, you also have to pound include standard integer.h, where these extra type names are defined. So we say this is junk, and all we want to do is to say scanf %c, read me a character, and put it into junk. And I don't even bother to see what it is because I know it is not the beginning of a base 10 signed number. And all I want to do with it is to throw it away. So after I throw away that one single byte or character that I don't need, I just go back and reattempt to read the next character as the beginning of a base 10 number. That's basically what this loop is for. Are there any questions about this loop? Yep.
Why do you need standard integer.h?
Because this type here is not a built-in type, it is defined by standard int.h. So that's why if you plan to use this particular type name, then you will have to pound include standard integer.h. Now if you use char here, the program will work basically the same way, and then you don't need standard integer.h. Right. Yep.
I'm just kind of off topic, but when you were talking about microcontrollers and how we want to go from like 32-bit to 8-bit, if we wanted to write a program for that, would we just initialize everything like that as an 8-bit integer or code, or how you have it initialized as 8 for junk?
Well, in that case, you want to determine what would be the maximum value that you have to store into sum in each entry also.
Okay.
Because right now I'm just using int. On most platforms it's at least 16-bit wide, so I know I can handle numbers up to about 32,000. But on the other hand, if you know that the entries can have up to, let's say, 1 billion as a value, then you will have to use int 32_t to make sure that you can handle that correct range, that range of the values.
Okay.
So you're absolutely right. I mean, this is not going to be platform independent because I'm just, with a 32-bit platform, int is 32-bit wide. With a 64-bit platform, int is 64-bit wide.
Okay.
So if you want to make sure that you make it completely platform independent, then you have to change every single int to specify the exact width that you think is appropriate for it.
Okay.
Okay. Now, after we do all the calculations, we better do something about sum, because otherwise we have all the calculations and it's not being used in any way. The program or the homework specification simply says you have to print it out. So we'll just go ahead and print it out, and we're done. That's all we need to do. There's no need to say the sum is or the total is. You just print it out, and that's all I need. If you do any extra work that is not conflicting with the description of the homework assignment, you're not going to get any points off deducted. Yep, go ahead. Okay, because I figured you were trying to ask that question. All right, so this will meet the minimum requirement for this particular homework assignment. Let's see if it works. So we'll go ahead and do a G++ -1 all pedantic -02. Now the O2 is here because I want the compiler to do flow analysis. So in case I am trying to use a variable before it is initialized, the -02 combined with -1 all will warn me about that sort of potential problems. In other words, I am trying to rely as much as possible on the compiler to catch potential problems. And it didn't catch a single one. Well, that's good. And we'll run the program, ask me about maximum number of entries. Here's a question. What if I enter -5 here? And then we specify 1,000 or 10,000 for threshold. What happens when I press the enter key? It will get to the finish, and it will print what?
Well, you're already past your max amount of entries. So
Exactly.
It will print 0.
It will print 0, exactly, because sum is initialized exactly to 0. So it's not an error condition, it's just doesn't make sense, okay? But this is the behavior of the program when you enter a negative value for maximum number of entries, and threshold is the same way too. So if I enter maximum entries to be 10,000 and -5 to be my threshold, same thing happens, because the sum was initialized to 0. And 0 is already greater than -5, so the program just exits the loop right away and prints a 0. Okay. Well, let's try something more meaningful. Let's try 5 and 5 here. I'll give it a single entry that is already exceeding 5 as a threshold. It should get out of the loop and print the total, which is just 45 in this case. That's what it does. 5 entries and 5 as a threshold. And this time I'll give it all zeros, right? 1, 2, 3, 4. This is the 5th one. Once I press the enter key, it should come up with a total of exactly 0 and get out of the loop. And it does. So are there any questions about this particular program? Let's see what happens when I give it something other than a number, because that's the error checking part, and I'll be checking for that one too. So 5 and 5, and I'll give you a really, really tricky one, okay, in this one. So I'll specify ASDF, we know this one, -5, 0.6, for 0.3, E23, and then we'll say multiplied by 3.14. Yeah, I think that's good. That is a good one. Okay, 1, 2, 3, 4, 5. Okay, and let's say 4, 5, 6, whatever. Okay. So as soon as I press the enter key, what do you think it is going to print? Or is it going to come back and say, oh, we need more numbers? If you are the if you are the computer running this program, then you will start parsing from the beginning, right? So you will first see the lowercase a character. I'm going to bring this up a little bit so that people in the back can see this more clearly. There we go. So this is our first character. And because a is not the beginning of a signed integer, we'll basically say, okay, we cannot read it as an integer. It will get into the while loop, and in the while loop, it will just read a single character. In this case, it's the lowercase a character. And then we just toss it away. We just say, throw it away. So the next time we get around to try to read the integer, it will encounter s as the beginning. Once again, this is a alphabet character. It is not cannot be the beginning of an integer, so it will go through the same logic, right? It will go into the while loop, read the byte, and toss it away. Same thing for D, same thing for F, and then eventually we come around to read the negative symbol. When we try to read the negative symbol, when we're trying to look for a signed integer, it's actually okay, not a problem. Because you can enter -5 as an integer, right? -5 is a signed integer because signed means it can be negative. So it's okay, and then it will read the 5, which is okay also. Okay, -5 is definitely an integer, not an issue. But as soon as it hits the period or the decimal point, then it will give up and say, okay, this is not a part of the integer. It will stop right there. And so the first number that we're adding to sum is -5. That is our first entry. It will add -5 to sum, go back to the beginning of the for loop, the outer loop, and then try to scanf %d again. So the second time we try to do a scanf %d, it will try to scan a period as the beginning of a signed integer. Is that the case? Nope. Because signed integers do not have decimal points. So once again, it will consider this quote unquote an error condition, and then the error condition code will handle this by basically just eating this byte and say, okay, it's not useful, and then we'll move on to the next one, which is just 3. 3 itself is a signed integer, not a problem. It's just 3. But E is not. So it will stop here and say, okay, the next integer is just 3 itself because E is not a part of the next integer. And then 3 will be added to sum. So right now sum is going to be -5 plus 3, which is -2. Are we still doing okay so far with that? Is that good? Okay. And then it will see 2. 2 is definitely a good beginning of a signed integer. Then it will read the 3 after that and say, oh, 2, 3 together is an integer also. Then it will try to read the next one and say, that cannot be a part of an integer. So 2, 3, or 23 is going to be the next integer. So that means our total will now become 21. Okay? It will read this byte, toss it away, and then read this byte here, and add it to the sum. So we have 21 plus 3, which is 24 as our sum at this point. And then it will read the period and say, oh, that cannot be a part of the integer 3. So it will just toss it away. And then read 14 as one single integer. So we have 14 plus 24, which is 38. Okay. So right now the total is 38.
Wouldn't we already have gotten out of it, Minor?
Yep, because now we have 5 integers.
Well, no, we would have gotten out at 23 because we're well over our threshold.
Oh, you're right. It does not.
Would have equaled 19.
You're right. You're definitely right. Okay, so it will read the 23 and it will print a total of
19.
21. -5 plus 3 is -2. -2 plus 23 is 21. Yep, so it will print 21 in this case. But if I ask it to read more, okay, let's make the maximum entry of 5 and threshold to be a much larger number. And we use exactly the same string here. Okay, so let's test it with exactly the same thing. So we can say copy and paste, and then press the enter key. This time it will read -5 as one integer, 3 as one integer to have a total of -2. -2 plus 23 is 21. 21 plus 3 is 24. 24 plus 14 is 38. It will stop here because this is our 5th integer already. So it will print 38 in this case. Press the enter key, and it's exactly 38. So that really kind of shows you the trickiness of reading integers from standard in, because what appears to us as valid numbers, because we know how to read decimal numbers, does not make any sense to scanf, and scanf will do what it needs to do to get the right input. Are we doing okay so far with these? code. Yes. Right.
Are you gonna have a grading rubrics for this then too?
Yeah, the rubric will be published. I mean, it will be. It's going to be based on the description itself, so it's not going to be based on something other than the description. All right. So that is your. This is the minimum. Okay, for this particular homework assignment, this is the minimum that a program has to do to basically get a perfect score. There's no need to print error messages. That's optional. And there's no need to say 38 is the total or anything like that. Just give me the number and it's all good. Any questions about this? No questions? All right, so if there are no questions about this, I'll leave it the way it is at this point, and then I'll go ahead and talk about the next slide, which I just wrote this morning, so that we can have a new homework assignment. Now, it is not really just for a new homework assignment. I do want to talk about this stuff here, because what if you're not using scanf? What if you're using C in and C out? Well, someone is going to say, but Tac, I choose to use just scanf and printf, so I don't have to learn about C in and C out. Well, you can't do that with your homework assignment. But what if you're picking up a project at work and it's already using C in and C out? Then you don't have a choice, right? So if you are to maintain that program, you don't have a choice to say, oh, I want to switch to scanf and printf. You cannot do that. Well, not practically. So what you need to do is to say, okay, we know how to do all the error handling in scanf now. I mean, this section you don't have to read because we talked about it already on Monday. This is just a type up to recap, basically what we talked about. So what we do need to talk about is how to do it in Cin, or using the C++ concept of a stream, which in this case is called Cin. Now with Cin, there are three concepts that you have to understand. Okay, so this is important. The first one is if you use Cin as a variable, but in a context where a Boolean value is needed, then it will return a true/false value. But in this case, the true value means the previous read operation was successful. A false value means the previous read operation was not successful. It's kind of like scanf returning a 1 versus scanf returning a 0 in this case. So in this particular context, the first line is attempting to read something from standard in as an integer and store it into I. Is that okay so far? I mean, that part, because I declare I as an integer, so it knows that I'm trying to read an integer and store it into variable I. If that was not successful, like if I type ASDF on the keyboard, then considering Cin itself as a Boolean will return a value of false. And as a result, we get to the else branch here, which is basically what you need to do if you did not read a number into variable I. On the other hand, if I type 1, 2, 3 on the keyboard and then press the enter key, then Cin into I is going to be successful. If the read operation is successful, then casting Cin into a Boolean is going to return a value of true. And in that case, I go to the then branch, which is this branch here. Then you can actually make use of the value of I. Now this is kind of tricky, right? Because we have Cin, which is essentially representing the standard input file. But when you use it in the context where it is considered as a Boolean, it will suddenly change and go like, oh, okay, so I see that you want me to report back whether the previous read operation was successful or not. Let me tell you, true, yes, it was successful, or false, it was not successful. Are we doing okay so far? Do you guys still remember coercion, typecasting, and that sort of thing? This is basically one of those situations where the syntax of the language, okay, but let's see what the compiler is seeing, okay? The compiler sees the if word and say, okay, this is a conditional statement. Now I am expecting an open paren, something that can be interpreted as a Boolean expression, close parenthesis, a then statement, an optional else keyword, and an else statement after that, okay? That's what the compiler is thinking. It's thinking ahead of time. And sure enough, it sees the open paren, which is good, and then it sees cin, which is a variable. Okay, the type of cin as a variable is what we call an I stream or an input stream. Oh, but we're expecting something that's Boolean. An input stream is certainly not something that is Boolean. So what the compiler would do at that point is to say, do we have any automatic way to convert an input stream into a Boolean value? Well, the language itself does not specify any way to do it. But the input stream code as a class, it has a method that says, oh, anytime you want to consider an input stream as a Boolean, this is the logic to do that, and this is the value that we should be returning. So it's actually implicitly going through some logic, some actual program code to say, oh, let me check whether the previous operation was successful or not. And if it was successful, I will return true.
Can you say that again?
Okay. Let me see if I can make this slightly more explicit. Pad. There we go. All right. So the question here is, okay, let me just type up the original code first, and then I'll do the extra code here. Okay. Now cin has its own type, and you can easily look up the type of cin. It's called an I stream or input stream, because you can just go to Google and say, type of cin. I mean that should automatically, it goes right to C++ reference. I mean, which is one of the best place to look up definitions. Like that. All right. So cin has a type of I stream. This is how you read the definition here. I stream is the type of cin. Does this look like Boolean to you, or integer, or something that can automatically be converted into Boolean? Nope. Okay. So that means the compiler is now saying, okay, let's see if we can cast it to a Boolean. Okay. Now, in the process of casting it to a Boolean, let me see if I can find that. We are actually, I have to use a concept that we have not talked about. It is object-oriented programming concept that you have to learn eventually. So I'm just going to give you a little fast forward on that topic. Okay. In C++, which is object-oriented programming, the difference is a type can be based on another type. Okay, which is a great thing. You can, sorry? Inheritance, exactly. So we have inheritance in a programming language like that. And as a result, when you look up what is an iStream, it will say, oh, iStream is a class, which is basically a type, but it's based on iOS, okay? Input-output stream, okay? And when you look up input-output stream, it has one particular method that is of interest to us at this point. And when it loads, we can explain it. Okay, there we go. All right, so when we look up the documentation of iOS, which is a base class of iStream, okay, we can see member type operator bool. There we go. So operator bool is going to turn a iStream into a Boolean value, which is what we want to do. And when you look up that operator, it's still working. It basically, the documentation will confirm what I just said. Okay, when you look at the cin variable, which is of the type iStream, and every time you want to see it as a Boolean, it reports back whether the previous read operation was successful or not. It's not loading. Let's try again. Or I can try DDoS. Click, 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 click. If you guys do it at the same time, it's truly a DDoS, a distributed denial of service attack.
What does that mean exactly? We're just constantly bombarding the server
Yeah.
with requests.
Yep, that's what a DDoS. Well, that's a DOS, but a DDoS means multiple computers are doing the same thing, so it's distributed.
Mm.
Yeah, those are really good concepts to know because computer security is a big thing. Okay, so this is the operator, and it returns whether an error flag is set or not. Okay, and that's exactly what we are trying to determine. So when you look at the return value, it returns a null pointer if at least one of the fail bit is set, some other value otherwise. So non-zero. A null pointer is basically 0, and anything other than a null pointer is a non-zero, which means it is true. So that's what we're getting to here. Okay, get back to the notes, which is here. So that's why we can use this particular construct to tell whether we read a number correctly or not in the previous read operation. Are we kind of doing okay so far with this concept? Let's do a program. Okay, let's run a program, and they will illustrate this particular concept. And this is something that you can also do when you do your homework assignment and you encounter a concept where it's kind of confusing. There may be multiple ways to look at it or you interpret one particular statement. Then you just say, okay, we'll check it, right? We'll just write a very simple program to say, okay, which way is the correct interpretation? So we need IO stream as the header file, and then we specify in main. And in here, all we want to do is to read into an integer and see whether we read it correctly or not. So we have int I, and then we say cin. Oh, since I did not specify the namespace, I have to use std : in front of cin every single time. So we are reading from standard in into variable I, and now we say if std standard cin, then we say something else, we say something else, and then we return a 0. And over here we can just say cout we read integer value I, and std : and L for end line. So you can see that without changing the namespace default, it is kind of tedious, but it's doable. It's not undoable. It's just kind of troublesome. So with this one here, we simply have to say did not read an integer. Okay, there we go. So this is a fairly simple program, so that we can use the Boolean cast operator of cin to determine whether we read something correctly or not. And you can probably map this concept to the return value of scanf, because scanf returns a particular value depending on whether it was able to successfully read what you asked it to read. Okay. So this is closely related to that concept. It's just that it's done in the C++ way instead of a C way. G++, let me take up the G++ command here, and this time we have cin.cpp, run cin. Okay, let's give it just a regular number, not a problem. 45, it prints read integer value 45, just as expected. But this is already an indication of several things. One, it is not a syntax error. Okay, you can use cin all by itself in the context of something that expects a Boolean, and it will automatically somehow turn cin as a non-Boolean thing into a Boolean thing. And in the process, it seems like it is reporting back whether it was reading something correctly or not. But this by itself is not a confirmation of that, because we also needed to give it something other than a number, so that it goes to the else branch, so that we can prove that it returns a 0 or false when it is not a number that it can interpret. And that is the case also. Are we doing okay so far with this sample program, C in which only serves one single purpose of double checking whether we can consider C in as a Boolean, and if so, does it really indicate whether we read something correctly or not? Okay, now that we have this one out of the way, we have the second concept. The second concept is, in this context, if an integer was not read, cin will basically lock itself in an error state and refuse to read anything any further. So any attempt to read a single byte as a character would also fail, because that really should not fail, right? Anything can be interpreted as a single byte, as a single character. But cin, unlike scanf, can lock itself into the error state and say, I'm not going to do anything any further until someone tells me that it is okay to do so. Okay, so and to clear the error state, you have to use what we call a method that belongs to the cin object. Okay, and this is object-oriented programming. You're basically saying, we want cin to do something that it knows how to do, and that one something that it knows how to do is to clear its own status flag or error flags. All right, so to illustrate this concept, what we're going to do is we'll extend our cin-er program and say, okay, we did not read an integer, so let's go ahead and clear that at least one junk character out of the conveyor belt. So at this point, we're going to say, okay, here's my junk character here, and cin, read into junk, and just to be sure, I'm going to use cout again, and say, just read a character blah, and that blah is going to be junk, and then I will specify the end of line. There we go. I did not use clear, okay? I did not use clear explicitly, just so that I can show you that without the clear method, it won't do this, okay? Are we doing okay so far? Line 15 is almost exactly the same thing as a scanf with a %c, because we are reading just a character into a character variable. Is that okay? All right. If this is okay, we'll give it a try and see whether this works the way that we expect it to work, which is not desirable. Okay. So we give it 45. Okay, same thing before. Nope, that part is not a problem. We give it ASDF. Now, if it works correctly, it will print that it just read the lowercase a character, right? Because that's the first character that it encounters. But when we press the enter key, it gives me some kind of junky thing here. Okay, just read the character with a question mark. It certainly is not lowercase a. So that means the read character code is not working. That line is definitely not reading. This line, to be more specific, line 15 is not reading in a character into junk. So the way to fix it is to use the dot clear, so that input stream cin is now saying, okay, somebody told me that it's okay to read again. Okay, somebody acknowledged that there is a problem, and now we can read again. So we have to insert the code std cin dot clear in order for us to be able to read again. So let's give that a try and see if that actually fixes the problem. Okay. Rerun cin-er and give it ASDF just like before. ASDF, and this time it does read the character A. Okay, in other words, we are starting to clear all the junk character out of the conveyor belt, and hopefully at some point we can get back to an integer. Is that okay so far? Okay. So that's actually combining the second and the third point. The second point is to clear the status flag, and then the third point is to read just one byte in, so they can clear the conveyor belt one character at a time until you can get back to the integer. Okay. All right. So that looks like that's it. Well, there's a little bit more to it. When you look at cin right shift I, the greater than symbol is also called right shift. That is not a statement. That is an expression. An expression means you have a left-hand side, an operator, and a right-hand side. And in this case, it certainly fits that description. C in is the left-hand side, I is the right-hand side, and this is my operator. In a way, it is kind of like 1 plus 2, 1 being the left-hand side, 2 being the right-hand side, and the plus being the operator in between the two things, right? So normally when you have 1 plus 2, the expression itself has a value of
3.
3, exactly. What about x plus equal 1? What is the value of the expression?
X gets x plus 1.
But what exactly is that value? It's the new value of x
Yeah.
after the plus 1. Okay, so that's the value. Sorry, go ahead.
No.
So that would be the
x plus 1 as a value, right?
as, but x is incremented as well. So it has a return value of the new value of x after the increment. Right?
So it's x plus 1 plus 1.
Nope. I wouldn't call it that way. I think I know what you mean, and I think you understand it correctly, but I would not call it, the value of x plus 1. So let us revisit that. X plus equal to 1. Okay. So the question is, if I put this into another context, let's say y gets x plus equal to 1, what is y getting? That's the question. It's getting the value of x after x gets incremented. Yep.
So the value of y is x plus 1 because we just don't know what x. Whatever x is.
Correct.
Incremented 1.
Right. Now, if I give you something ahead of time and say, x has a value of k, then y has a value of
Okay, plus 1.
and x also has a value of k plus 1. Okay?
Okay.
All right. So now that we know what is the return value or the value of an expression, the question is, well, this is just an expression too. So as an expression, it has a value that it's coming back with. Now, it definitely has what we call a side effect of reading the input and putting an integer into I. Okay, it has that side effect. The question is, what is it returning as an expression? Now, this one is actually kind of tricky, kind of non-intuitive. It returns C in itself. In other words, if you look at this expression and not counting the side effect of reading something from standard in and putting into variable I, it is the same thing as C in. Yep.
Does it instantiate the object here?
Hmm?
Does it declare the object or?
Well, C in is predefined as an object, so that's why in our program, in our code, we just have to refer to it as std : C in, because it's an object that is pre-created before it gets to our code. It's kind of like a global variable. It's already predefined. Okay, but this is the important part, is if you use this expression where C in itself is expected, it will work. Let me say that again. Anywhere C in can go to, you can use this expression instead. And it will serve almost exactly the same purpose with the additional side effect of reading standard in and putting that number into variable I.
So we can like chain the second input right afterwards?
Yep. So that's why we can do something like this. Okay, let me just kind of scroll back to the original code here. In this context, C in is serving one purpose. Is telling us whether it was able to read successfully in the previous read operation, right? But we are using C in. And I just said that C in greater than I can go where we can put C in. So that means, hey, I can put this entire expression into here. Is that okay? Sort of. So instead of doing this code here, instead of doing this code here, I can now use this code. And I know exactly how most people think about this. It's like, great tech, you just saved one line of code. When I use all the open curly brace, close curly brace, and no matter whether there's actually an else branch or not, I put an else over there. So saving one line of code, what is the big deal? Well, there is a big deal, and it is closely related to your next homework assignment. Okay, so I'm gonna stop right here, talk about the next homework assignment, and then when it's time to relate back to this concept, I will point out why it is related. Okay. All right, so we are gonna open a second tab to the homework assignment first. So let's see. All right, your next homework assignment is called limited summation using cin. So you can probably imagine it's closely related to the previous homework assignment, the one that was due today. And in fact, if you read the description, it's exactly the same except for minor little changes. So instead of using sum as the directory name, you use cinsum as the directory name. And the last part of it, instead of saying that you are to use scanf and printf, now it is you are to use cin and cout. And instead of saying no cin or cout, now it says no scanf or printf. It's the reverse of the previous homework assignment. But the rest of the homework assignment is exactly the same. Okay? You're going to read the maximum number of entries, you're going to read threshold, and then you read the entries with error detection and ignore the erroneous letters. Yep. The line feed character is the \n. New line character is the same thing as a line feed character. Yep.
Are you particularly thinking about whether we do use line feeds or not, except for where declared? Because I put new lines in previous parts of the assignment. And that's the only space we actually said we had to have it. But
You mean this part here? You mean this part? So your program did not have a line feed?
Oh, it does.
No.
But
It does?
He's also got it on the prompt. Earlier parts as well.
No, that's fine, because the earlier part does not say that you cannot have a line feed. So if you have an additional line feed, it's going to be okay. It does not conflict with the description itself.
And when's this one due?
In a week. But you can use my code today as a starting point. Okay, now you kind of have to work what you're learning today into the homework that was due today, so they can work on the new homework assignment. That is the whole purpose. Okay, is to compare and contrast cin, cout versus printf and scanf. Okay, all right. So you can say that, oh wow, the logic is going to be about the same, because I just did it today. So you have to think about, okay, now, but we have to change everything that involves scanf into cin. The printf part is easy because it's just printing. There's no error handling of any kind. But whenever we use scanf in the previous program, the one that was due today, you have to switch it to use cin. That is why this can come in handy. Okay? Because if you do not use this approach by combining the reading and checking whether you actually read something into one single expression, then it becomes difficult to translate the code that we did today. Do you guys have any questions back there? Hello? No? Okay. Alright, so the code that we did today is in main main.cpp. Okay, so if you look at one particular line, let's say this one here, okay, this is combining the attempt to read an integer into num and the reporting of whether we actually read something into one single expression. Alright? I'm not gonna point out, where in today's note is related to this one, but I think most of you have an idea of how to map the concepts that we talked about today to this particular program. And you can, I mean, I'm authorizing you guys to use this as a starting point, because the whole point of this particular homework assignment is not the main logic of error checking, because we talked about it already. It is basically finding the equivalence of doing the same thing using cin instead of scanf.
So it's the same code. We're just basically comparing the two uses of cin and scanf.
Right. Well, there are some additional changes you have to make, like stdio.h is not going to work anymore. You have to replace the header file with something else. Anything that has scanf, you have to replace it with something that involves cin. Anything that has to do with printf, you have to replace it with something that involves cout. But otherwise, the logic of the program remains pretty much the same. Okay. Now, without a particular concept, without this concept here, and only be able to do something like this, it's still doable, but you will have to alter the control structure significantly to make it work.
Let's see.
Thanks.
And I think I've just come this close to actually saying the solution of this particular homework assignment, so I think I should probably stop right there. All right. Any questions about the new homework assignment? You have 1 week to work on this. I don't think it's going to take you a whole lot of time, especially once you understand, the topics that we talk about today thoroughly. Then it is not going to be, that big of a deal to work on this. But as one last thing, okay, because I always want to prove, whether the concept that I talk about in class would work or not. Let's go ahead and change this program just one more time by combining this statement to this statement here. Okay, because that's one thing that we were talking about, well, does it actually work? So we'll go ahead and recompile this code and test it again, okay? So we'll give it a regular number just to make sure that, if it does read a correct number, it should not give me an error message. Not a problem. And this time I'll run it again and I'll give it a SDF, and it should go to the part where it complains and then start to clear out the first character of the junk, and it does. So that means the logic has not changed by combining the reading with the error checking, and you have to somehow figure out how to work that into your homework assignment. Any questions? No questions? And what I'm going to do is to give you a view of the current solution first, just so that you can take a screenshot if you want to. And you can always replay the video and take a screenshot and then just type it in. I'm not going to give you the text file because I'm hoping as you type this in, you will start to kind of continue to think about it and say, okay, I'm starting to get how this program or how this code works. Any questions regarding cin, cout, scanf, or printf? No questions. Any questions about the object-oriented programming things that we talked about earlier? No questions. Inheritance, that sort of thing. No questions? Because okay, let me show you something, and it will kind of make a certain point of why it is important for you guys to know how to navigate on a website like this. Okay, if you look at how many methods or how many things IOStream can do, it's not really a whole lot, and then you work your way to the superclass like iOS, then you will start to see, hey, there's really quite a lot of things that an iOS or an input-output stream can do. Right? And then if you look at iOS, it is based on another base class, iOS_base, which is what we call a superclass of iOS. and that will give you some additional stuff that you can do. All right. Okay, so it has a whole bunch of other stuff that you can do. So now the question is, is it viable, or is it feasible for us to talk about every single thing that iOS can do, or something of the class iOS can do? Probably not. Okay, and that is going to be the case in most of your C++ classes, your Java classes, and so on and so forth. So now the question is, how do you look up things that cin can do? So the way you do it is do it exactly what I did earlier. You look up cin first. Once you get to the cin entry, then you can now say, oh, okay, but what is a cin? Cin is an object of class iStream. So you look up the class definition iStream, then you can figure out what cin can do, because that is a description of everything of that type. And iStream itself has already a lot of stuff that you can do. Okay, you can change precision, you can change the field character, and so on and so forth. But itself is based on the iOS stream, and in the iOS class, in the iOS class you can also find out what you can do with it. And eventually, okay, maybe not now, but eventually I want you guys to be able to navigate on a website like this and read the documentation by yourself. Well, tech, you're just a lazy professor. I mean, you want the students to look up everything and learn by themselves. But eventually, when you go to work, okay, no one is going to tell you the 20 gazillion things that you can do in Java, okay? So you will have to find out, how to read the documentation online and figure out, how to do things. And object-oriented programming makes it easier in one way to find out what you can do with something, and it also makes it kind of slightly more difficult because now it depends on, the concept of inheritance. A class can inherit from another class, that can inherit from another class. So what you can do depends on the entire hierarchy of the inheritance hierarchy of your base class. We'll continue to talk about this a little bit maybe this semester. That will be the focus of CISP 400. The object-oriented programming class will focus on concepts like that. Inheritance, what is a method, how do you override the function, how do you make typecasting to do something special, like in this case, right? I mean, casting an IO stream, a representation of a file, to a Boolean is kind of like, what is that going to do? Well, since we are overriding the concept of typecasting, we can make it report whether it was able to read something successfully before or not. So those are the concepts in CISP 400 that you'll be learning, when you move on to CISP 400. Any questions for today? Questions? Okay. Now we have an entire weekend to work on the homework assignment, so I strongly recommend you guys to get started early. So in case you have any questions, you can bring it on Monday, and we can address those questions. All right. I'll see you guys on next Monday. Have a nice weekend.